Hello there, YouTubers. For once, not so long time, but no see. I'm SuperDavo001, and I am here to teach you today about textures. And I forgot to do the usual thing of opening a program that's already got it working. Let me just get one up that I made a while ago. Where was it? Hold on, I'll get it. I'm back. Sorry about that. Oh, okay. Hold on. Never mind. What we're going to be learning is how to create textures and use them. That was an old project I made a while ago, and I don't know why it suddenly stopped working, but never mind. So, just to get back to where we were, this is exactly the same code as we had at the end of tutorial 1. But now we're going to enhance it with the abilities of textures. So first things first, I'm going to create a new file. I believe I'll create a header file. I'm going to create a header file called textloader.h. Now this header file is going to have a few includes to it. And let me see. First things first, we're gonna need to hashtag include sdl/sdl.h. We are also going to need to hashtag include gl/gl.h. Okay, also we're also going to need IOStream. Now first, what I'm going to do is I'm going to define a class. This is just something I've done for my own programs as well, because it gets a bit tedious setting all the properties manually, so I created a class that does it called text properties. And it's going to privately store certain values and then have certain public accessor functions. So in here it's going to have a, let's see, I think this has to be an int. Yeah. It's going to have a mag filter. You'll see what all these are soon. Then you have a min filter. Then a wrap. You'll see what these are in a minute. And finally, an Isotropic. You'll understand what all these are in a minute. But for now, we're going to have to create some functions. Firstly, we're going to need one of these that sets all of these up. Integer, nope. Integer. Perfect, that's text properties. Now we're going to need some getters. I'm just going to create a few getter files which basically literally just return the values of these top variables. Back in a second. And there we go. Easy enough. These functions, they all make pretty much perfect sense. You're literally just returning the values. Never mind that. The Isotropic Filtering value, the magnification filter value, the minification filter value, and the texture wrap value. These are all things that you're going to see again in a minute. And then right, we are going to need are we going to need anything else? Let me think. Hold on, just give me a second. You know what, I don't think we're going to need another thing. Now I'm afraid to say that we're going to have to create a texture loader, and a lot of this is SDL. But there are places where you can find these sort of things out for yourself to load bitmap files, but SDL provides it for you. So I'm going to use that, but if you just hold Hold on a second for me. Let me Google that for you. Give it a second. Try this one. Yep. See, this place has provided all this stuff for you. I've followed these tutorials quite extensively, so they are pretty good. But anyway, back to my tutorial. Now let's create a new file. This time it's going to be a C/C++ source, and it's going to be called textloader.cpp. Add to all. Text loader. And back in text, I'm just going to create the constructor next. I mean, this is just a simple class to do stuff you need to do. Oh, for goodness sake, what's wrong with IDE sometimes? For the record, I'm using Code Blocks IDE. Let's see. You know, I might just migrate all of these, except for the guards, down here, and then I will hashtag include. I'll include my old header file. And why have I done that? Oh well. So text loader : text loader. This is so easy. This.magFilter equals magFilter. You can see where I'm going with this, so I'll pause it for a second while I do it. And back. Well, that was an easy constructor to make. Let me just save this and there. So now to begin the uber important function. It is going to return an unsigned integer, and it's going to be called getTexture. Oh, and another include I'm going to need is hold on. SDL image. This is kind of an extra thing, which is an extension of SDL, but you could really do with it, because I always use it to download PNG file. Well, not download, but to load PNG files. There we go. And I'm also going to need to include it down here as well. And I'm also going to need to do, at the start of this, I'm going to need to do img underscore init. img underscore init underscore png. There we go. It basically initializes it so it can load PNG files now. And as parameters, I'm going to need a file name, and I'm going to need a text properties called properties. Might as well make the name simple. So this is the function where we load the texture. And now this isn't particularly simple, but it's not particularly hard either. But a lot of this is SDL, but later on you'll see the stuff that isn't SDL. The first bit's just simple SDL loading. So firstly, I'm going to create a GL int called number of colors, which for now equals 0. I think, if I remember rightly from when I made this is so I can tell whether it's a RGBA or just RGB. Well, actually, do I ever end up using that? We'll see. If I create something that I don't really need, I apologise. We're also going to need a GL enum called formats. It doesn't actually have to be an enum. I think it can be an integer as well, but this is just how I wrote it on my cheat sheet, so I'm using it this way. Next, we're going to need to create an SDL underscore surface called called image, which equals img underscore load, and then I pass the file name as the parameter. And then I don't know what this does, but it just does something. img equals sdl underscore display format alpha. I don't know why I have to do this, but I think it does help with this thing. And yeah. Now I'm just going to do an error check if statement here. First I might just do the using namespace, just put the standard library in. So basically if the reference of image equals 0, then I can see out failed to find image. So now that basically means you've failed to find the image that you're looking for. And then end the line. Nothing too complicated. Now then, I'm also going to create a couple of warnings, because a little thing with these textures is I'll show you the texture I have. This is my texture. It is a photo of Jupiter, but what's important about it is that the texture width and height are a power of 2. So that's 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 20, 48, 4096 or 8192 and so on, by those numbers again. So basically the width and height have to be a power of 2. And this is 512 by 512, which is quite a good size, I'd say. But yeah, that's a photo of Jupiter I've taken just to show you what certain things have to be true with textures. I think technically you can get away without them being a power of 2, but it's better not to. And if you want to really ensure that you do, then you might as well put a warning in. So in fact, you know what, I'm not going to bother. It's on my cheat sheet, but I don't really care. This is where the format comes in, the GLE If img I'm sorry about this. I apologize for the fact that I don't really quite know what I'm doing here. It just works. This is just code that I've seen and don't really understand, but it's not really the OpenGL bit. As I say, I've not really bothered to learn SDL. But don't worry, we'll get back to OpenGL soon. Actually, img format bytes per pixel. So if the number of bytes for every pixel equals 4, then that basically means that there's 4 colours. That's probably where the number of colours thing came in before. But remember before what I said about red, green, blue and alpha? Well, that. So, well, the problem is that the colours can be in different orders, because there's GL underscore RGBA or there's GL underscore BGRA, and 2 different ways of ordering the texture colours. So yeah. So to work out which one it is, I don't know why this works, it just does. But if img, again this is just SDL stuff, bear with me, img format rmask equals, and this is in hexadecimal, but it's 0.0000000 ff. That. Then, if that's true, then format equals GL underscore RGBA. But else, of course, the other option is Yeah, this is I think I might actually have to use number of colours. But number of colours equals not 5 equals 4. That's weird. Then else, then do the rmask thing again. Well, I'm going to do it slightly different this time, because if img format rmask equals no ff, then format equals RGB. So it's either a red green blue, a blue green red, or a red green blue alpha, or a blue green red alpha texture. And then again else some textures are BGR, others are RGB, just so you know. I've seen them be both before. Oh, but I think this is just mucked up. Let me have a look. Yeah, that should be there. No, it shouldn't actually. And I'll just put this down here. I think I have to move that one up and that one up. Sorry, this is just confusing me now. Effectively, I'll move that down, that down, that down. I'm really sorry about this, it's just messing me about. That down. That's better. And then set the number of colours equal to 3. So that's the OpenGL stuff. That's not OpenGL, the SDL stuff taken care of pretty much now, so we can move on to the bit that really matters to you. And I apologise for wasting 15 minutes of your life, but it'll be worth it, trust me. So now we'll go create an unsigned integer called ID. This is actually going to be the number that we return, but we've got to do some stuff with it yet. Next thing we do is called GL textures. And then we're generating one texture and passing a pointer to the ID. That basically just allocates the space for the system to store the texture, and whenever you make changes it will allocate them in there automatically. Then the next thing you do is you GL bind texture. GL texture to D ID. So now it's bound, so what that means is that if you make any changes using any texture calls, it will always affect the bound texture, which is ID. Same counts for if you draw it, it will always draw the bound texture. So yeah, then the next thing is to set several parameters for it. GL text parameter I. And then GL texture 2D. And then you'll see what this is in a minute, but GL generate mipmap. So sets generating mipmaps to true. What are mipmaps, you may ask? Well, don't worry. Paint to the rescue, only it's actually paint.net this time, because paint.net supports transparency in layers. So yeah. Let's see now, mipmaps. When you zoom out, if you have a texture like this, when it gets further away, it gets smaller. So if you're looking at this thing from a longer distance, you'll see that it's more like that. But the problem is that because of the way it shrinks it down, at some point it's just going to start blurring up and it's going to become really grainy. And it also slows down your performance a lot. So what it does is for this texture, it basically generates another texture half the size. Generates a texture half the size of that. Generates a texture half the size of that. And half the size of that. And half the size of that. And half the size of that until, you know, there's barely anything there at all. And then it would use something like this texture and it would draw it to the shape. rather than drawing the big one, because that not only improves performance, but it stops it from mucking up as well. Hold on. I might actually return to Paint. Don't save. So back to this. I'm probably going to have to draw another diagram in a second. But first, now I'm going to do another GL text. Another GL text parameter, only this one's a float. This one is again a GL texture 2D, but this time it's different. It's the next parameter is GL. I was going to say texture mag filter. And now this one, you may remember we set mag filter in text properties. So we're going to use the properties dot mag filter. So, and that can be set to one of two values, GL underscore, I was going to say nearest, or GL underscore linear. This is where I'm going to have to return to Paint to show you how these work. Here you have nearest and linear. So say I have a texture here. It's got pixel there, pixel there, pixel there, pixel there. It's a very small texture. And say to the pixel of the screen I was drawing this point. And let me just mark out the central points for each texture as that. That and that. So basically they're the central position of the pixel of the texture. Now there's two options, and these govern the interpolation, as it's called, of the texture. There's GL underscore nearest and GL underscore linear. And so nearest, what that does is it basically picks the nearest pixel, and basically in this case it will draw to this pixel, because this you'll draw to that one, simply because it's inside the, simply because the center of that one is nearer than the center of the others around it. It simply picks the nearest center. But for GL linear, it'll basically average out the values of those pixels, but it will alter them based on the distance. So that one will be influenced the most. That one will influence a bit. That one will influence even less, and that will influence slightly more. And it basically blends the pixels together out of the nearest 4 pixels. So that's how they work, but GL linear produces much smoother results than GL nearest. So yeah, that's that explained. That's what the mag filter does. But the mag filter only works when the grid of pixels is larger than the actual screen itself. So these pixels are clearly larger than 1 pixel of the screen. Otherwise you've got the minification filter, which works the other way around but in a similar way. So now to set the min filter. GL texture 2D, GL texture min filter. Properties.min filter. And then the next one's going to be the next one's actually 2. It's the wrap one. So I'm going to copy this over. But I'm going to change this to GL underscore texture wrap S. Now I've only done one wrap, even though it's got one wrap for each axis, just for a good reason. You'll see why in a second. Because, no, why is it, what? Gosh, this does weird things sometimes. But, yep, wrap T. What does that do? Well, texture wrap is basically what happens when, in fact, you know, I'll tell you about something else first that's you need to know. Because basically, when I draw, say, a square, you have to give it something called the UV coordinates, and basically the values between 0 and 1 usually. So if you're on the very left of the texture, you go for 0, 0, the very top left, and the very bottom right of the texture is 1, 1. And those are UV coordinates, and you can pick any value in between them and stuff like that for it. But what if you want to pick, say, 10, 10? Well, you have a couple of options here. The first option is GL underscore repeat. GL repeat. What that does is it will basically repeat the texture, so that if you're doing it up to 1010, it will basically repeat it 10 times. So it'll be as though you've got a texture there, texture there, texture there, texture there, texture there, texture there, and so on. The second option is GL underscore clamp to edge. GL clamp to edge, what that does is basically if a value is 1010, it'll basically say screw that, that's bigger than 11, just use 11. And so once you go beyond it, it'll just look kind of the same. So 1010 will be the same as 11. 20,000 by 20,000 will be the same as 11, and so on. And then the final one is GL underscore mirrored repeat. I'm not even going to bother writing it. And that one, basically, if I have a texture, let's see. If I have a texture and I draw it up to about here, so I have two versions of it that are touching each other, and this texture is, say, an arrow, just random shapes I can pick up in Paint, and the arrow is drawn that way. GL mirrored repeats will draw the arrow facing that way on the second one, and if you drew a third one, it would be back to facing the other way, and then so on and so forth. It basically reflects it a bit. Whoa, 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 whoa. Now most of the time we're just going to use GL repeat because it's simpler. Now the next parameter is GL text parameter F. Now this one is actually an extension, and I wonder if it's supported without GLE, I don't know. You'll see what I'm talking about soon. Hopefully it's supported, but you might need it eventually anyway. But GL texture 2D GL text, this one's quite a long name, Max Anisotropy X, and then say it to properties dot anisotropy, and that's max anisotropy done for you. Now what is anisotropic filtering? Well, it's based around bitmaps, because I said if you have a bitmap like that and then it does one that's half, and then does one that's half, then does one that's half, then does one that's half. Well, it will also do one that's half in one direction but full in the other, so it'll do ones like that, and even smaller. Pardon me. And it'll basically do all these combinations of all these different different shapes and sizes of textures until it's covered basically all of them. And what that does is it means that if you're looking at it from a really steep angle, so it's kind of like that. Pretend this is a square plane. It's kind of like that, that, and that. I'm not an artist, but basically it'll stop the texture from blurring out. And the higher the levels of anisotropy, the better that is, and don't worry about that blender thing. That's just something I keep clicking on by accident. But yeah, that's anisotropic filtering setup, if it works. Although actually I think I'm going to have to do get. I'm going to have to use the getters, aren't I, because I put these in private. Hold on, I'll fix it. Fixed it. So that's them. That's the parameters set up, and now that we've set everything up for the texture, now we run GL text image 2D. And then it's GL underscore texture 2D. This is basically loading the texture into it. The next one, this is quite a long function as you can see. The next one is the level of bitmaps. That's going to be 0. The next one, that one's GL RGB or GL RGBA, so now I'm going to have to use a ternary operator. So number of colors equals 4 question mark, and then value if true is GL underscore RGBA colon GL underscore RGB. Then the next argument is the width of the texture, so that is literally just the original STL surface dot W. And then the next one's height. Work that out for yourself. The next one's the border. I don't know what that does, but it's always set to 0. And then the next one's the format, as determined earlier. Then the next one is the type of texture, and this kind of depends on the texture. I don't know, but I know GL unsigned byte is a perfectly good value for that. And then the next one's the data, and that one's stored in the SDL surface here as IMG pixels. No, not pitch. And congratulations, you've now set up the texture. So now, if I just SDL underscore free surface, just free the SDL data because it was stored as a pointer, and then return ID. So now we have text loader set up. So now I'm going to have to now the rest of it is mostly quite easy. But first we're going to need a text. I'm going to call it linear because the setting's going to be linear. Set up the constructor. The mag filter is going to be GL underscore linear. The min filter is going to be GL underscore linear mipmap linear. That basically, the bit after the mipmap could be mipmap linear or mipmap nearest. If it's nearest, then it kind of makes it a bit grainy, and it's not as good. Actually, no, that's the other one. This one determines how the mipmaps are joined together. So, if you have it as nearest, you can see the dividing lines. If you have it as linear, you'd need to be an expert to spot them. And after that, the next setting is going to be the wrap, which is going to be GL underscore repeat. And then the next one's the level of an isotropic filtering. And now this the maximum you can use for this varies between computers, but I know mine's 16. So that's the properties set up. And now I'm going to create an unsigned, unsynced. I'm going to call it Jupiter, because that's what the texture is. Now in the init function, I'm going to go Jupiter equals get texture. It's called Jupiter.png, and don't forget you have to make sure you know where the folder is, which folder it's in. And then there's the properties, which are my linear properties. And then after that, you have now initialized it. You have now initialized the texture. So now to draw it, this is where firstly you're going to need to draw a quad. Now, because I cannot be bothered to show you how I do that, I'll just do it myself. And there we go, that's a quad, and it will be at right angles to the triangle. Or will it? I don't think it will actually. So I'm going to have to do the GL rotate F again, and I'm going to rotate it by 90 on the y-axis again. So that's 0, 1, 0. And then after that, I'm going to bind the texture. So that's GL bind texture, GL texture 2D, and then Jupiter. So now the texture's bound and can be used. Now we need to specify the UV coordinates, which I just told you about. And they're done in the same way as vertices and colours. So it's going to be text chord 2F. And then again, this is just a two-digit value, so don't forget. Just remember about the square with the, hold on. I give up trying to draw. 0, 0 for top left, 1, 1 for bottom right. I think so. So the first one's going to be 0, 0. The second one is going to be 1, 0. The third one is going to be 1, 1, 1. And the fourth one is going to be 0, 1. And yeah. Congratulations, you have now loaded a texture. Now let's compile this and see if it works. Just as I anticipated. I'm probably going to need to specify this in the header file. Not too hard. Oh, have I said... GL underscore BGRA, did I? What? I'm confused. Yeah, I'm confused by this, so... Okay, that's thrown me off a bit. Just give me a second. I'll try to fix this. Well, first things first, I just found another bug. Maybe it's related, who knows, but you need 2 equals on here. I apologise. Of course, I still have this problem, but it's only true for BGR. Error number 2 is don't put these things into these brackets. I've still not solved the main error though. Oh, and I could probably also do with leaving the brackets in themselves. Oh my gosh. Brackets, just don't fill the brackets. Like I did. It's called being an imbecile. Still has the main error though. Just give me a minute. Got it. So apparently I needed SGL underscore OpenGL.h included as well. Never mind. I think what it is that SDL underscore OpenGL contains all the OpenGL stuff up to version 2, whereas GL/GL.h only contains the very, very early stuff. I'll show you how to use GLEE next time, which adds yet more stuff. So now it compiles. Let's just see if it runs properly. Will it work? No, it draws a blue rectangle. Feel free to laugh at me. Well, it draws a rectangle, alright, so, you know. Let's see, what's the problem now? I've bound the texture. Just at the end, I'm going to unbind the texture by doing GL bind texture. Aha! And I know what I forgot now as well. There's one more thing, because you need to actually GL enable the texture. GL enable GL texture 2D. Hopefully it'll work now. Yes, and indeed you may be wondering why the texture might be slightly blue, but that's not a problem. All that is because because when you change GL color 4F, the color stays the same until you change it again. So I'm going to need to change it down here to GL color 4F, and then change it all to white. Red, green, blue, and alpha all to 1. And now, congratulations, you've just added your texture. I might just try to change its shape slightly. I think it needs to be slightly less wide. Yeah, so Control C, Control V, Control V, Control V, hopefully that'll be it. That's better. So yeah, once again, you have now drawn a texture. Congratulations. And it's also slightly upside down, but feel free to reorient the UVs and stuff to make sure it's alright. So yeah, thanks for watching. This tutorial's been even longer than the last one, and I apologise, but your code now looks a lot better. Next thing we're going to be looking into is probably an introduction to shaders, which I'm afraid is going to be another long and difficult tutorial, but again, keep persevering. Keep following these tutorials until the end, and it will all pay off, and you'll be able to do some seriously awesome stuff. So yeah, thank you for watching. Please subscribe. Make sure you know when the next one's coming out. Thank you for watching once again, and thank you for watching, and also thank you for watching. Anyway, I'll see you next time.